Today we are going to see in detail about the solution to second order differential equation, that is Bessel equation and Bessel function. Already I have uploaded this lecture earlier, but I like to make lot of improvement in that lecture, so I did that improvement and I removed the old one. Now we are going to see my new one. And the following is the Bessel differential equation, which has this form, that is x squared t2y over tx squared plus x dy by dx plus x squared minus nu squared y, which is equal to 0. This is a second order differential equation, which can be written in a simple form square y double prime and x y prime plus x squared minus nu squared multiplied by y, which is equal to 0. Here y is the special function and nu is the order of the Bessel function. Now our task is to find the y, that is the Bessel function. Uh, so the solution for above equation is about differential equation is y is equal to summation over n 0 to infinite an x power n plus r. Now our task is to find an and r. So with that introduction, we will move on further. So this is our Bessel equation. I am going to apply a small mathematical trick here. That is, I am going to combine these two terms and I am separating this term. That is x squared minus nu squared y into x squared y minus nu squared y. And I am going to combine this first two term as x and xy prime of prime. That is the thing here. So you can easily verify how I am replacing this. So you take xy prime of prime. That is a facial derivative of xy prime. So what you will do, first you keep x as it is and differentiate y prime. So this will become first term x in first term in the bracket will become x y double prime plus next what you will do, you differentiate x, so x prime, and you keep y prime as it is. Here one interesting thing is what is x prime. Definitely x prime is equal to 1 because you are taking derivative with respect to x. So this must be 1. So I have made in the oval shape. So this is you can replace this by 1 and multiply with the x. So the first term become x square y double prime. Then second term will become x y prime, which is exactly same as this one. So there is no difference if I replace this by this one, which I have shown in the red color rectangular box. Then we will move on further. You can understand why I am doing this. So now we have rewritten the Bessel equation in a convenient form. You can understand within few minutes why this is a convenient form. So we have already seen y is equal to solution for this equation is y is equal to summation over n 0 to infinite an x n plus r. Now I am taking y prime. So if you differentiate this, what you will get? That is a derivative is with respect to x. So this x power n plus r will become n plus r x into x power n plus r minus 1. So an you are keeping as it is because there is no x dependence on an. So this is y prime. Then our task is to find x y prime. X y prime is just you multiply this by x. That is y prime by x. So naturally x into x, this x into x power n plus r minus 1 will become simply n plus r because you are multiplying by x. So in the power minus 1 will go away. Now you take a derivative of this one. So that is our next task. If you take derivative, see here you have x power n plus r. So if you differentiate x, it will become n plus r x n plus r minus 1. So here already there is n plus r. So that will become n plus r whole square. And here, of course, you will have minus 1. Now, our first term is x, uh, x multiplied by the xy prime of prime. So, this x into y prime of prime is equal to this one because I am multiplying this by x. So, naturally, this minus 1 will go away. This will become simply x n plus r. This is about the first term. We will see what will happen to these terms. So this is our Bessel function, Bessel equation. We have found just now the first term, that is x into x y prime of prime. We have found as summation over n equal to 0 to infinite n plus r squared into an into x n plus r. Similarly, with the solution y for this Bessel equation is y is equal to, that also we have seen, y is equal to summation over n equal to 0 to infinite an plus x n plus r. From this only we arrived at this one. Now you substitute these two in the equation, first equation, that is Bessel equation. Then you will get the red color. I am replacing the first term by this red color bonded summation. So I have replaced this, and y I have replaced this one, that violet color summation. So I have introduced it. Here you remember this is x squared. There is one x squared I have taken outside the summation and new squared. So what I am going to do now is I am going to bring x squared inside the summation. So naturally here x in x power n plus r is there. So this will become n plus r plus 2 because we are bringing this x squared here. So this is the final expression we arrived after some rearrangement and mathematical tricks. So this is our Bessel equation. Uh, we have found the first term, which I have shown in red color, bond summation in the red color. This is the first term, and second term is this one, violet color summation. And third term minus new squared, this summation over 0 to infinite an x power n plus r, which is equal to 0. Here the each coefficient of x must be equal to 0. Though we have written in summation, in order to satisfy this equation, each and individual component of same power of x must be 0. So I have taken the first term in the column. That is, first term is x x y prime of prime, and second one is x squared y, x squared y. Third term is minus nu squared y, so minus nu squared y. You remember that here is a negative sign. So now I am going to equate the individual component of x. In the first row I have taken x power r. See, when n equal to 0, I have taken the first term, first summation term. when n is equal to 0, this will become x power r. So naturally, this coefficient of x power r is, since we have taken n is equal to 0, this will become simply r squared a naught because n is 0, a naught. Then when n is equal to 1, what will happen? That is x uh, power r plus 1. N is equal to 1 will become 1 plus r whole square a1. Similarly, when n equal to 2, that is x power r plus 2, this will become 2 plus r square because n is equal to 2 uh, into a2 because n is 2. It will go like this. So, generally, if x is r plus n, r n plus r, this will become n plus r whole square a n. This is a general term. Now, I come to the second one, x squared y. That is this summation. Here, when n equal to 0, what will happen? R plus 2. This x is power x power r plus 2 because n is equal to 0. So you cannot find first two term here. Uh, then when n is equal to 0, automatically this will become x power r plus 2, not x power r plus 2 will come. So n equal to 0, here only one term is left. So this will become a naught. Similarly, second one, if n equal to 3, this will become a1, n equal to uh, 4, it will become a2, like that. That is always it's n minus 2. So here I have written it is a n minus 2 uh, because here you have n plus 2. So naturally it will come n minus 2. Then I will come to third term, minus nu squared y. So what will happen when n equal to 0? N equal to 0 means, here you remember, n equal to 0, x power nu, x power r. So x power r is equal to nu squared will come as it is a0. Here only an is there. So a0. Similarly, n equal to 1, that is r, this will become n plus r become r plus 1 because n is 1. So this will become nu squared a1. Similarly, this will become nu squared a2. Like that it will go. So general term is nu squared an. So you remember this table. Now we will try to find the solution for the same. So this is the table which we have constructed. This is first term of the equation. Remember that this is second term, this is third term. If you add all the three, you will get the Bessel equation, solution to Bessel equation. Uh, Particularly, you have to equate the same power of x. So x power r, you take x power r, just add these two terms. So this will be r squared minus nu squared. Remember that there is minus here. Minus nu squared is equal to 0, provided if a naught is not equal. If a naught is not equal to 0, non-zero quantity, then r is equal to plus or minus nu. Remember that it is plus or minus nu. So you take the second one. Then this is 1 plus r squared minus nu squared a1, which is equal to 0. Here you can see uh, from the first x power r, we have found r is equal to plus or minus nu. You take now in our entire lecture, we will take nu as a positive one. So that is another important point. Well, I am going to highlight. So this r I am replacing as nu. So this is 1 plus nu squared minus nu squared into a1 is equal to 0. What is it means? So then the bracket term will not go to 0 because this is 1 plus nu squared and it minus nu squared only. So this is having definite finite value. So naturally, another alternative is A1 must be equal to 0. Uh, so this is very very important. See, the all odd number of term will be equal to 0. That is A1, A3, A5. You may ask why. Just within few minutes I will explain. All odd term will go away. Only even term exists. So this is our table. First, we have found the solution for first two term, that is x power r and then x power r plus 1, because here this x squared y x coefficient is 0 in this case. So we are going for general solution, which is equal to, if you add all these three, n plus r squared. Remember that this is an term only we will take. That is first, that is here is second row and fourth row. So which contain an term. So you take an as a common, then you will get in this row you have n plus r whole squared, n plus r whole squared. Remember that there is minus, so this will become minus nu squared an plus in the third row you can see only just an minus 2, which is equal to 0. Then what is an? If you bring this to the right hand side, this will become minus an minus 2, and this you bring it to denominator an in order to find the an. Because I told our ultimate aim is to find an and r. R we have already find the value of r, but that is nothing but nu. So here I am replacing r by nu. So and if you square it, n plus nu squared is equal to n squared plus nu squared plus 2 nu minus nu squared. So this green color I have made highlight in the green color. Nu squared will go away. Only you will have n squared in the numerator. You have only n squared plus 2n nu. We will see what will happen to this. Just now we have seen this solution. An is equal to minus an minus 2 divided by n squared plus 2n nu. Now you take n outside. Then inside the bracket we have n plus 2 nu. So this will be n squared plus 2n nu. So I am taking n as common factor here. Here you can see in the right hand side numerator you have n minus 2. So naturally the minimum n value must be 2. So n must be equal to or greater than 2. Uh, Now, just to, few minutes back, I told that for odd number of the coefficient will be 0. A1, as A1 is equal to 0. Just now we have seen A1 is equal to 0. Similarly, A3, A5, A7. I can uh, show an example of two value. Let us take, because n max minimum value is 2. You take add value n equal to 3. Then this will become right hand side n 3 minus 2 1. So a1 already 0, so naturally a3 also 0. Now you take a5. Then here numerator 5 minus 3, 5 minus 2 is equal to 3, a3. So just because just now I told that a3 is 0, naturally a5 also 0. So you will have 0 for all odd number. You will have a solution only for even number. First, you take minimum a2. You substitute n equal to 2 in this formula. Then you will get in the numerator a naught. Here n is 2. 2 into 2 plus 2 nu. which is equal to uh, equal to here I am taking this 2 outside because this is 2 plus 2 new. I am taking that as 1 plus new. So 2 will come out. So 2 into 2, 2 square. Here I am multiplying this by 1. Naturally, 1 that is 1 factorial. You can understand why I am using factorial here. 1 factorial is after all 1 only. So now, A4, you find the A4. Naturally, A3 is 0. Now you find the A4. You substitute 4 here for n. So in the numerator, you will have n minus 2. That is 4 minus 2, 2. Here, n is 4, 4 plus 2 new. So this 4 I am writing as 2 squared. 2 squared is 4. I am taking this 2 outside. That is I am writing as 2 factorial. So 1 into 2, 2 factorial. So naturally this will be 2. I am taking 2 as a common from this value 4 plus 2 new. So that 2 comes out. So within the bracket you will have 2 plus new. Now you substitute the value for a2 here. Remember that here one minus. So here one minus. This will become plus. So this will become a naught. Already 2 squared is here. Here 1 2 squared. So 2 power 4 you will get. Here 1 factorial. Here 2 factorial is equal to 2 factorial. That is 2 factorial is equal to 2 naturally. 2 into 1. This one. Okay. Now here you have 2 plus new, here you have 1 plus new. So 2 plus new, 1 plus new will come. So you will get A4 is equal to this one. Now next naturally A5 will be 0. So A6. Here in this equation you replace n by 6. So this will become 6 minus 2, 4. So minus A4 divided by this one 6 plus 6 plus 2 new 6 plus 6 plus 6 into 6 plus 2 new. So 6 I am writing as 3 into uh, 2. 3 into 2 I am writing 6. Here one 2 I am taking out from the bracket. See, then inside bracket you will get 3 plus new because I am already taking 2 outside, and also I am writing 6 as 3 into 2. So this 2 and this 2 will become 2 square. Here is A4. I know the value of A4. A4 is this one. Just to replace, then this will become here minus a4. So this will become one negative sign, minus a naught divided by 3 into 2 factorial. Remember that 3 into 2 factorial is 3 factorial. Here you have 2 power 2, here 2 power 4. So which will become 2 power 6. Then here 3 plus new, already there is 2 plus new into 1 plus new. So this will come like this. From this, you can easily guess what is A2K. Why I am replacing 2K means you will have only even number here. You can take K equal to 1, 2, 3. Naturally, 2K is an even number. So uh, here you can see another thing, minus a naught plus a naught minus a naught. For a8 again it will become plus a naught. So alternate plus and minus will come. So I am writing that minus 1 power k. So this will take care of alternate plus and minus a naught divided by, you can see this is here k value is 3. So this will become 2 power 2k. You can rewrite. See A6, 6k is 3. 2 into 3 is 6. So 2 power 2k. This is k factorial because here k is 3 only. So 2k is 6. So k factorial, 3 factorial, like k factorial. You can compare these two. So you can generalize this solution as 2 power 2k, k factorial into k plus nu, 3 plus nu, 2 plus nu, and 1 plus nu. This is the general solution. That is a 2k. So finally, we got this coefficient expression, and it's customary to assume A naught is an arbitrary constant, which is equal to 1 over 2 nu uh, multiplied by nu factorial. Then this equation become like this. See here, I have introduced replaced A naught by 2 nu 1 over 2 nu and mu prime, and I reversed the this denominator, that is k plus nu, which will go to up to 1 plus nu. I bring the reverse it, 1 plus nu, 2 plus nu, 3 plus nu, up to k plus nu into nu prime. This green color part can be written as k plus nu factorial. So this will reduce the coefficient will reduce into the nice form. That is 2k is equal to minus 1 power k divided by 2 power nu multiplied by 2 power 2k into k prime into k plus sorry into k factorial into k plus nu factorial. So we have seen in the coefficient, we find the coefficient a2k. So this one. Now already we have seen the Bessel function y is equal to summation over n equal to 0 to infinity a n x power n plus r, and we proved that only even coefficient is exist, odd coefficient will become 0. That is n will become 2k, 2 times k. So now I have changed the running index n to k, k equal to 0 to infinite. A 2k x, this n also n I replaced it as 2k, 2k plus nu. So now you substitute A2K here in the green color part. A2K is this one I am substituting in this summation. So here you can see already there is 2 new times 2 power 2K. So 2 power new times 2 power 2K, which is equal to 2 power 2K plus new. Remember that x also here. So just I have rewritten this like this. Now we will further simplify this one. So we arrived with this expression, that is summation y is equal to summation of this term. Now here you can see 2 power 2k plus nu. Here also x power 2k nu. So I bring both as a common, x by 2 2k plus nu power x by 2 power 2k plus nu. Here you have minus 1k and k factorial multiplied by k plus nu factorial. This is the Bessel function J nu of x, where J nu of x is called Bessel function of first kind. This is Bessel function of first kind. Here we have made this is a real number. Nu is a real number and integer. So first kind of order nu. So similarly, we can find the expression for what will happen if nu is a negative number or half integer. So uh, just I am going to stop here. We will see more about Bessel function in my future lecture. This is the derivation of the Bessel function. Thank you very much for watching my videos and supporting me continuously. If you have any question, please send to the following mail ID vasimku@gmail.com. Kindly subscribe my channel. Channel ID is youtube.com/at Vasu V Physics. Thank you very much for your support.